Day 487 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3025. Find the number of ways to place people 1. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a 2D array points of size n by 2 representing integer coordinates of some points on a 2D plane where points of I is equal to I, xi, yi. Count the number of pairs A and B where A is on the upper left side of B and there are no other points in the rectangle or line they make including the border. Return the count. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input points equals a 2D array of integers, first array being 1, 1, second array 2, 2, third array 3, 3. Our output is 0. Our explanation gives us this nice picture graph right here so we can see what's going on. It says there is no way to choose A and B, so A is on the upper left side of B. So as you can see, all of these points right here go up to the right. There's no points on this graph where it goes to the left of another point. All of these points go up and to the right. So there's no way to choose an A and B, so that A is on the upper left side of B because all of these points all go up and to the right. So let's take a look at example 2 where there is a way to choose A and B so that A is on the upper left side. And then we need to return how many ways there are. So in example 2, we have our input points equals a 2D array of integers 6 and 2. Then the next one is 4, 4. Then the third array is 2, 6. The output is 2 because there are 2 ways to choose A and B so that A is on the upper left side. The explanation gives us these nice pictures again, so let's take a look at them. Let me see if I can zoom in for y'all because I know it's kind of hard to see. Just like this. I think that's as far as it. Oh no, we could go a little further. Boom. All right. Now, let's see. It says the left one is the pair of points of 1 and points of 0, where points of 1 is on the left upper side of points of 0, and the rectangle is empty. So let's see what points of 1 is. So this is points of 1, 4, 4. Boom. So 4, we come over. This is 4, 4 right here. You see? So we have a point right here, 4, 4. Then it says points of 0, right? So points of 0 is this right here, 6, 2. So we come right here to 6, 2. Boom, come over 6 up 2. As you can see, 4, 4 is on the upper left side of 6, 2. So that's a pair that we can form. And also, we need to point out that there are no other points inside the square or along the rectangle of this square. Along the border of this square, which is this requirement right here. There are no other points in the rectangle or line that including the border. So as you can see, this square is empty. There's no other points. So it fits that requirement. It fits the requirement. As you can see, this is going down to the left, whereas up here it was going up and to the right. So this is this passes both requirements. Points of 1 and points of 0 pass both requirements because points of 1 is on the upper left side of points of 0. So let's take a look at not example 2, the next set of points that fit our requirements. So the next points that fit our requirement are, it says the middle one is the pair points of 2 and points of 1, same as the left one is a valid pair. So once again, this is a valid pair as well. So we have points of 2, which is index 2 right here, 2, 6. This 2, 6 right here, as you can see, come over 2 up 6. So we have a point right here, 2, 6. Then we have points of 1, which is 4, 4 again, right? So points of 1, 4, 4. Boom, right here, as you can see, 2, 6 is up and to the left of 4, 4. So that's a valid pair because there are no other points in the square or along the border of the square. So let's take a look and see why this does not work, right? So it says the right one is the pair points of 2 and points of 0, where points of 2 is on the upper left side of points of 0, but points of 1 is inside the rectangle, so it's not valid. So this is an example of where the point is not valid because there is a point inside the square, right? So it's, once again, it says there are no other points in the rectangle or line they make. So this makes a square or a rectangle, right? But there's a point inside of it, so it's not valid. We only want points that have no other points inside or along the border of it. So in this case, the output is 2 because these are the only two pairs of points that we can create where they fit these requirements up here, where A is on the upper left side of B and there are no other points in the rectangle or line. So let's take a look at example 3. It's the last example, but this example gives us shows us a case where we're using, it might just be a line, right? So it says in example 3, we have an input points equals an array to the array of integers. First array 3 and 1, then next one 1 and 3, last one 1 1. The output is 2. Let's take a look at this explanation, right? So it says the left one is the pair points of 2 and points of 0, where points of 2 is on the upper left side of points of 0, and there are no other points on the line they form. Note that it is valid state when 2 points form a line. So boom, since they form a line, it says that's a valid state, right? So that counts, that's good. We have points of 2, which is 1 1, and then we have points of 0, which is 3 1, right? So we have the 1 1 right here. Boom, as you can see, is 1 1, and then we have the 3 1 right here. Come down 3 up 1. Boom, they form a horizontal line that counts, and as you can see, the third point is all the way up here. It is not along the line, so it's a valid pair. Boom. So let's take a look at example or the next valid pair where it's a vertical line. It says the middle one is the pair points of 1 and points of 2. It is a valid pair, same as the left one. So in this case, we have a vertical line, but it's still valid. We have points of 1, which is 1 3, and then we have points of 2, which is 1 1, right? Boom. So once again, we have 1 1, we have 1 3 right here. It's a vertical line that counts, that's valid. And then we have the point, the last point is all the way over here. It does not intersect with this line, so that's a valid pair. So let's take a look at this third pair right here that is not valid, because as you can see, there are points. There's a point on the inside on the border of the rectangle. So it says the right one is the pair points of 1 and points of 0. So points of 1 and points of 0 is 3 1 and 1 3, right? So we have the 3 1 right here and the 1 3 right here. Boom. It says it is not a valid pair as points of 2 is on the border of the rectangle. So points of 2 is this 1 1 right here. And as you can see, it's inside, or it's on the border of, it's on the border of the rectangle, and that's what makes it not a valid pair. If it wasn't on the border, then that would be a valid pair, but it is, so it's not. So I hope that makes sense to y'all. Let me zoom back out. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. As I'm sure y'all are aware, the solution is not going to be that difficult. So I hope you're excited about it. Now let's get into it. Now the first thing we're going to do is we're going to sort the points primarily by x in ascending order, and then if the x's are equal, then we're going to sort by y in descending order. And this is going to ensure that for the same x and higher y comes first. So we're going to say, come inside this function, we're going to say let should be lowercase, let sorted points equal points dot sorted, open up the parentheses, we're going to say by colon, then we're going to open up the brackets, we're going to say x comma y in, boom, then we're going to say if x square bracket 0 equals y square bracket 0, that should be square bracket 0, then we're going to open up the brackets, we're going to return x square bracket 1 is greater than sign y square bracket 1. Boom. Then we come right here on this if statement. We're going to say else. Then we're going to open up the brackets. We could say we're going to return x square bracket 0 is less than y square bracket 0. Boom, just like that. Then we're going to come underneath this. We're going to say let n equal sorted points dot count, and then we need a counter that's going to keep track of our output for us, or the counter of valid pairs. We're going to declare a variable called num of pairs. We're going to set that equal to 0 to start. Now we're going to iterate through all pairs of points. So we're going to say for I in 0 dot dot up to n minus 1. We're going to open up the brackets, and we're only going to consider pairs where point of I is above or at the same y as point j. So for example, point I is the upper left relative to point j after sorting by x. So we come right here and we say for j in I plus 1 dot dot up to less than sign n, where sorted points square bracket I square bracket 1 is greater than or equal to sorted points square bracket j square bracket 1. Come outside of that, we're going to open up the brackets, and if I and j are adjacent in sorted order, then no immediate points exist, so it forms a valid pair. So we're going to say if I plus 1 equals j, we're going to open up the brackets. We're going to say num of pairs. We're going to increment that by saying plus equals 1. Come underneath that, and we can say continue. Boom. Otherwise, we're going to check if there exists any point k between I and j that lies within the vertical strip between yj and y of I. So come under this if. We're going to say declare a variable called no pair found. We're going to set that equal to true. Then we're going to come underneath that. We're going to say for k and I plus 1 dot dot less than sign j. We're going to open up the brackets, and we're going to say if sorted points square bracket k, come outside of that, square bracket 1 is greater than or equal to sorted points square bracket j square bracket 1, and we come underneath this just to make it easier to read. We're going to say sorted points square bracket k, square bracket k, come outside of that, square bracket 1 is less than or equal to sorted points square bracket I square bracket 1. Then we're going to open up the brackets, and if a point is found blocking the rectangle region, we're going to set it to false. We're going to set no pair found. We're going to set that equal to false. Come underneath that, we're going to break. Now, if no blocking point is found, and I and j forms a valid pair. So we'll come right here, and we're going to say if no pair found, then we're going to open up the brackets, and we'll say num of pairs plus equals 1. And then we need to return the total valid number of pairs that we have found by coming right here, and all we have to do is say return num of pairs, y'all. So that should be all she wrote. Let's give it a run before we submit it, make sure it works. Let's see, it's accepted, y'all. That's what I'm talking about, first try. So let's go ahead and submit it, make sure it's still accepted. And look at that, y'all. 7 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So before we go, make sure you get one more look at the code. It's the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.